Hi there. To start this video, I thought we would do a quick history lesson. Content delivery networks, or CDNs, have been around for quite some time now. Since the late 90s, when the first generation CDNs were introduced to help reduce latency associated with media transfer. Traditionally, static material was retrieved directly from origin each time a user requested it. That took way too long. The CDN reduced that round-trip request time by caching frequently used items at an internet exchange location. Now to the current state of CDN. Amazon CloudFront speeds up content delivery by leveraging its global network of data centers known as edge locations. CloudFront has edge servers in locations all around the world. Let's take a look. CloudFront fetches your content from an origin, such as an Amazon S3 bucket, an Amazon EC2 instance, an Amazon Elastic Load Balancer, or your own web server, and stores it in the edge location. CloudFront can be used to help optimize your application's performance and security while effectively managing costs. We recommend that you also set up Amazon CloudFront to work with your Amazon S3 bucket to serve and protect the content. By design, delivering data out of CloudFront can be more cost-effective than delivering it from S3 directly to your users. When a user requests content that you serve with CloudFront, their request is routed to a nearby edge location. If CloudFront has a cached copy of the requested file, CloudFront delivers it to the user, providing a fast, low-latency response. If the file they've requested isn't yet cached, CloudFront retrieves it from origin, and as an added benefit, data transfer from S3 to CloudFront is often more cost-effective than serving files directly from S3. So it's a win-win. CloudFront also leverages AWS Global Private Network, a separate backbone across the internet that helps bypass worldwide networking issues to provide better performance for both static and dynamic content. To help clarify how this works, let's take a look at the scenario shown in this illustration. We've stored our content in an S3 bucket located in a European region, and we have users located around the world who have access to that content. As the arrows show, whenever a user requests content, the request must go over public internet to the source location, in this case, the S3 bucket in Europe. Depending on the user's location, this can take a long time. Now imagine we set up CloudFront in front of that S3 bucket. Much better. You can see now that there are no longer requests traversing the globe to get our content. Instead, requests are routed to the least latent edge location, that is, the closest in terms of delivery speed. CloudFront then serves cached content quickly and directly to the user nearby, as shown by the green arrows. If content is not yet cached with an edge server, CloudFront retrieves it from the S3 bucket origin. And because the content traverses the AWS private network instead of public internet, and CloudFront optimizes the TCP handshake, the request and content return is still so much faster than crossing the public internet. Let's talk about securing your content. Often companies who distribute content over the internet want to restrict access to documents, business data, media streams, or other content so that only selected users, like paying customers for example, can request that content. By using CloudFront, we can set up additional access restrictions like geo restrictions, signed URLs, and signed cookies to further constrain access to the content following different criteria. Another security feature of CloudFront is Origin Access Identity, or OAI. Let's take a look. OAI restricts access to an S3 bucket and its content to only CloudFront and operations that CloudFront performs. CloudFront includes additional protection against malicious exploits. To provide these safeguards, CloudFront integrates with both AWS WAF, a web application firewall that helps protect web applications from common web exploits, and AWS Shield, a managed DDoS protection service for web applications running on AWS. The goal here is to place layers of protection between your user requests and the data origin but to do it in such a way that it does not impact performance. AWS WAF lets you control access to your content based on conditions that you specify. For example, IP addresses or the query string on a content request. CloudFront then responds with either the requested content, if the conditions are met, or with an HTTP 403 forbidden error. All CloudFront customers benefit from the automatic protection of AWS Shield Standard at no additional charge. I hope that now you're as excited about CloudFront as I am. And as you can see, CDNs are incredibly important to our internet infrastructure and service. In fact, you're probably viewing this course through a CDN distribution now. Now that we've got a good footing on CloudFront, I'd like to show you how to enable this very powerful service in our next video. See you then.